Hello, everyone. My name is Artis Harold, and I'm on the NESTA board. Elaine Bowles-Graham recently introduced herself. If you missed Elaine, she is also on the NESTA board, and we are the facilitators for today's Mars workshop. I'd like to take a minute and introduce our first presenter and primary presenter, Jackie Kane. Jackie is a colleague who taught high school science in the Toledo area, Toledo, Ohio. And she primarily taught 7th through 12th grade, recently retired, and she developed a real appreciation of exploring Mars using a professional tool that's free and available for you to use on just a website. And Jackie's going to talk to us about it. First of all, I'll turn it over to Jackie and let her introduce her co-presenter.
Thank you, Artis and Elaine, and your NESTA organization for this opportunity for me to share how teachers and students can stir curiosity while building upon prior knowledge and developing science skills. For thousands of years, we have worked to unravel our Earth story. With the aid of applications such as JMARS, students can use their knowledge of Earth to unravel Mars' story too. With us today, we are honored to have a member of the JMARS team, Scott Dickenshied.
So yeah, as Jackie said, I'm Scott Dickenshied. I work at Arizona State University in Tempe, Arizona. I'm one of the developers on the JMARS project. I've actually been on the team for 15 years, and the project existed before I joined. So JMARS has actually been a publicly available tool for 18 years now. It was originally written and it's still maintained as a mission planning tool for the NASA Themis instrument, which is orbiting Mars and has been orbiting Mars since 2001. So it's used actively to plan for that mission. It's also used to do some planning for the EMIRS mission, which arrived at Mars earlier this year. We also are used for analysis for the HiRISE instrument at the University of Arizona and a lot of other instruments around Mars. We also do a similar version of this tool called JASTEROID, which was involved with the OSIRIS-REx mission. We're actually involved with the Lucy mission, which is launching next month. We're going to be involved with the Europa Clipper mission. So this application, even though its origins are with Mars, and it's actively supporting Mars development. It's much bigger than just Mars. If you like it for Mars, you can expand to other planetary bodies. Even though we actively support NASA missions, we're also very motivated to support teachers bringing school kids and adults into exploring the data that's been collected as well. So we're here to support you and here to support Jackie in her efforts to make this all more accessible to you and to your students. So hopefully you find it to be a useful tool.
These slides will show you how to start using JMARS. JMARS is a scientist tool that is free, easy to use, and is an open source system that is safe and easy to download. JMARS is an acronym that stands for Java Mission Planning and Analysis for Remote Sensing. It is a geospatial information system developed by Arizona State University's Mars Spaceflight Facility to provide mission planning and data analysis tools for NASA scientists, instrument team members, and students of all ages and the general public. To get the most from these slides, you should bookmark the website listed here and download JMARS from tab 2 on the website. JMARS can serve as a good model to study the Earth and connect to current events. JMARS is a professional tool, but it can also be used by middle and high school age students and their teachers to access and analyze planetary data. The website is a set of simplified directions for using many of the tools on the current JMARS version. The homepage lists many important links, such as teacher resources. Tab 2 provides an introduction to Mars, JMARS, and downloading directions. And in tab 3 are direction pages for many of the JMARS tools and data. JMARS models data as images. Here you see 4 images with different data displayed on globes. The first one is imaged using visible wavelengths. The second image shows elevation data where low elevation is colored blue. High elevations are colored red and white. The third image shows dust coverage on Mars, where red indicates much dust. The last image shows thermal inertia data, where purple indicates areas that lose heat quicker than the blue and green areas. This is a screenshot of what you see when you open JMARS. Along the top, there are tools. On the left, in the black vertical menu, are different data sets called layers. The green area is the main screen where the data is displayed. There are two other features in the lower left corner that will be discussed next. There is more explanation on the Wix website, as well as an excellent, more extensive tutorial located on the JMARS website. Let's start using JMARS by practicing with the search, zoom, nomenclature, and opacity tools. As of October 2021, this is how the screen looked. First, let's change the location. Move your cursor to the upper left corner where there is a search box. Highlight the 00 and type in 7, space 288. 7, space 288. Click Enter. You can also type in landmarks such as Olympus Mons by clicking on the magnifying glass and typing in the name. Click the icon to close. Let's zoom out. Move your cursor to the upper right zoom box. Click on the down arrow and click 4. Notice there are many crater labels. Let's get rid of all the crater labels and choose volcano labels. The JMARS has layers placed over the main window that add map features such as labels and scales. These features are in the lower left section called Overlays. Find the Nomenclature layer. Slide the white opacity button to the left. To hide the labels, slide it back to the right to unhide. You can also hide and unhide the labels by clicking on and off the white button with the M on it. Double-click on the word Nomenclature. In the lower left corner of the pop-up screen, scroll and click on the word Mons. Close the window. Now volcano-like features are labeled. Hide the labels again. You can also use the opacity slider on the other layers. To minimize the overlayers for now, click on the triangle next to the overlays layer. Let's see what happens as we slide the buttons on the opacity bars for each layer. The top layer is what is displayed in the main window. The Explorer layer is unique in that it is a combination of many data sets so that it can be displayed with the best data for that zoom layer. Hiding the Explorer Mars reveals the color map. The color map creates the most natural looking view of Mars. Hiding the color map reveals the colorized elevation map. This is similar to the Explorer Mars layer, but if you zoom in on it, it gets pixelated. When viewing the temperature layers, it is best to zoom in. To hide the daytime layer, you can see the nighttime temperature layer. The brighter, whiter areas are areas that are hotter at night. Closing out the temperature layers to get the thermal inertial layer and zooming back out, you can see the effect of areas that keep their heat or lose their heat. In this case, the purple is an area that loses their heat quicker than the red and the green layers. Before going on to the next slide, practice using these tools and have fun exploring Mars. To determine the surface distance, let's again look at location 7, space 288 with a zoom level of 512 and the Explorer Map opacity slider to the right. Find and click the ruler tool near the upper right corner. Place your cursor on the crater rim. Click, hold, and drag the cursor across to the other side. The distance is displayed in the lower right corner. It is a good idea to click on the cursor arrow in the menu bar after finished using a tool. In a profile, click on the profile icon in the tool menu. Click or double-click on your image where you would like to start drawing your profile. Move your cursor to where you want the profile to end and double-click. The line turns color. To show the profile, go to the blue lower left corner labeled Quick Access. Click the solid white profile icon. A profile shows in a pop-up window. To improve the quality of the profile, go to the pop-up window, click the blue box labeled Set Numeric Map Source. Click on the third row, called HRSC MOLA Blended DEM 200M V2. Highlight and then click OK. You can see the profile has more data points than the default data. You can also move your pencil along the line and you get matching lines drawn on your pop-up profile. Before going on to the next slide, explore these tools elsewhere. Ask your own questions and then find the answers. For example, what is the ratio of the depth to diameter of craters? Are there any patterns? Remember, it is the journey that is the joy. JMARS can be displayed in 3 dimensions. To do this, go to the Explore Mars layer. Click on the 3D button to turn on 3D. The button turns white. In the Quick Access section at the bottom left corner, click on the cube, the mask, and the globe. There should be 3 pop-up windows, which may be behind your JMARS screen. In the 3D option pop-up window, go to the bottom of the window in a section labeled Vertical Exaggeration and type in a value of 66. The default is to create a total exaggeration for twice this amount. To improve the results, find and click the blue outline box labeled Set Vertical Source. Click on the third line down labeled HRSC MOLA Blended DEM 200M V2. Click OK. This data has finer resolution. Find the 2 pop-up windows. Click, hold, and move the cursor in these pop-up windows to rotate them. Before going to the next slide, explore other Mars locations in 3D. Let's look at 2 layers that are not in the default layers. These are 2 of many that are available. If you registered for JMARS, you can save these extra layers as favorites. The first one is the temperature calculator. JMARS scientists have taken the data from Mars and created equations that yield average daily and yearly temperatures for any location on Mars. To view these charts, use the Explore Mars layer and zoom to 4. Turn off labels. Click the blue bar labeled Layers. Type in Temperature Calculator KRC. It should pop up. Close the window. Double-click on this new temperature layer name in the Layers section. Let's compare the temperature at the base and at the top of Mount Olympus, which is the largest volcano in the solar system. In this view, Olympus Mons is located in the middle of the upper left section with a white top. Using your cursor, click on a spot to the right and bottom of Olympus Mons. In the pop-up window, click Add. Next, click on the top of Mount Olympus. Click Add. In the KRC Layers option window, click Results. Click on and highlight both data rows. You may have to hold down the Command key on a Mac as you click to select both rows. Click Run KRC. It might take as much as 15 seconds or so. These graphs lend themselves to many questions and observations. For example, point 1 graph is higher than point 2. Is this what you would expect? Point 2 seems to have a minimum limit, but point 1 does not. You can also switch to the Year tab. Another fascinating layer is a combined night and day temperature layer. This layer has combined the day and night temperatures so that the warmer nighttime data is colored red. Often, less dusty, more rocky areas are hotter at night and hence red in color in this image. These steps and others are posted on tab 3 of the website. See if you can follow them to produce an image like this. Now it is easier to know how the surface material inside the crater is different than the surface material outside the crater. Before moving on to the next slide, explore this layer more. This has been a short introduction to JMARS. There's much more to explore. For example, if you go to the top menu, choose Body, then select Body, you can also explore some 30 other planetary objects in our solar system. The most exciting part is that now you are equipped to ask your own questions about these places and search for the answers using JMARS. It is the most fun when you own your own exploration journey.